Okay, tangent of theta, cosecant of theta, cosine of theta. So a lot of times what I'll do, did y'all have the other thing written down or do I need to rewrite it?
I have it.
Okay, so when we verify, we only change one side. So a lot of times what I will do is, like, we're going to manipulate the left. To make sure that I don't try to do anything on the right is I will go ahead and draw an arrow down so that I know that that 1 is coming down. So basically, kind of like what I was talking about with those pre-cal problems where it was like telling me like, oh, you need to solve this problem so that it's equal to like 1 or negative 1. In a sense, that's what this is doing. It's telling you your left side when you are done needs to be equal to 1. So I like to look at how can I rewrite things to see if things will cancel or whatever. So what's something up there that I can rewrite in terms of another trig function or other trig functions? So 1 over sine theta is cosecant. See, cosine I'm just going to copy down because obviously. What about, is there a way to rewrite tangent? Yep, sine of theta over cosine theta. So then, I'm going to see what I can cancel. So sine of theta's cancel, cosine theta cancels. So you get left with 1 is equal to 1. And then I usually just put a giant check mark to show that it worked. Or that I verified it.
So even though the cosine's not, like, in the, like, I don't know how to explain it. Like, it's not beside the one with...
Yeah, because it's all being multiplied.
Okay.
So as long as it's all being multiplied, it can cancel.
Oh.
And I could technically do this if I wanted to make it more clear that. All right, let's see. 28. Sine of pi over 2 minus x times tangent of x is equal to, sine of x. So again, I'm going to bring this sine of x down. So I want to rewrite stuff. So, like, how would I rewrite the sine of pi over 2 minus x? Yeah, the cosine x. And then what about tangent?
Sine x over cosine x.
Yep, sine x over cosine x. So then my cosines will cancel. So then I get sine of x is equal to sine of x. And then 30, 2 minus cosine squared of theta is equal to 1 plus sine squared of theta. Now, I will tell you this one is one that you probably won't naturally see, okay? And that's because, I mean, 1, you haven't been working with them very long, and then 2, it's very different than what we were just doing. So I ultimately need it to be 1 plus sine of theta, right? So I need to figure out what to do about the left side. I see squared values, and squared makes me think what? By the Pythagorean identities. So I'm sitting over here, and I'm like, well, there's not a 2 in the Pythagorean identities, so I can't really do anything with that. But would you agree that 2 is equal to 1 plus 1? So what I can do is rewrite this as 1 plus 1 minus cosine squared of theta. Then what do you see? So 1 minus cosine squared of theta would be? You have to manipulate one of the originals.
Sine squared theta?
Yep. So sine squared plus cosine squared is equal to 1. So if I do 1 minus cosine squared, it would be equal to sine squared. So then this part here, this 1 minus cosine squared, is becoming a sine squared of theta. And then I still have the 1 that was out front that I split. And so Now they're equal. So if you see a number like other than a 1, look to see if it's something that you can split. Okay, if there's not like a 2 on this side. Like if there had already been a 2 over here, I would have been like, okay, whatever. But there wasn't. So I'm like, okay, well, can I split this into something like simple math, just 1 plus 1, but that's how you rewrite it to get it to work. And a lot of people question why they have to do this, and there's not really a good answer for you. It's just purely to verify that these identities are true.
If it was like, for some reason they put the number like, let's say 5 in there, could you split it into like 1 plus 4 so you have that 1 plus?
Yep. Yeah, that ends up happening a lot actually.
Oh.
And then when we get later in math, sometimes there's some more verifying that happens with some other identities that you get later in the chapter where like a 2 is involved, so then you have to leave the 2. But it won't be with a squared term. It might be. The identities that are later in the chapter are much harder to remember, in my opinion. Like, I never remember them until I start using them a ton. These ones, most of them I remember off the top of my head. The ones that we do later, no. Like, I have ways to remember them, but I don't remember them just in general. All right, we've got 2 more of these. So, sine squared of negative x over tangent squared of x is equal to cosine squared of x. All right, so first and foremost, what does the negative inside of a sign do?
It makes the sign negative.
Okay, it makes the sign negative. So I have negative sine squared of x. Now, something that I need to show you is that, because I don't remember if I've written it this way before or not, sine squared of x written like this is equal to sine of x squared. But it's not equal to sine of x squared. Okay, so if you have the 2 on the sign, it's the same thing as putting it outside. Okay, so the reason I say all of that is because with this here, I have this negative now. The negative is also being squared. So what I would almost do when you end up with one of these that has the negative with it is to rewrite it like this so you don't forget to make it positive. Now, if you see it right away and you want to go ahead and make it positive, that's fine. But for the sake of if you go back and look, I want you to have the detail of why it happened. So then I have that over tangent squared of x. I forgot to bring this down. So this becomes sine squared of x over tangent squared of x. But actually, how can I rewrite tangent? Tangent is equivalent to what?
Sine with x over both sine of x.
Yep, and since it was squared, it'll just be sine squared of x over cosine squared of x. If I divide by a fraction, I keep change flip. So I'm going to have sine squared of x times cosine squared of x over sine squared of x. Sines cancel, leaves you with cosine squared of x equal to cosine squared of x. All right, the last one is sine of x over 1 minus cosine of negative x is equal to cosecant of x plus cotangent of x. This is going to be a semi-long problem, just so you know. All right, so just initially, what do you think the first thing we should do is? And what happens if you have negative inside cosine?
It stays the same. Like, so the negative x with
Just-
cosine, it's just cosine.
It just disappears. Yes.
That took too long to explain.
I was like, gosh, what are you talking about?
All right, sine of x over 1 minus cosine of x. Okay, and the minus is just because it was already minus. It just stays the same of whatever it already was. All right, now this next thing, I'm not exactly sure how much we've really covered it, to be honest, so you may not think to do this, okay? But I know that just off the top of my head, I see no way to get from here to here. So what we can do is we can multiply by the conjugate, okay, which is multiplying by the opposite of this. So multiplying top and bottom by 1 plus cosine of x. So that's essentially all I'm doing is I'm multiplying by 1. So I'm going to leave the top alone. I'm just going to leave that as like sine of x times 1 plus cosine of x for the moment. On the bottom, do you remember what special factoring type this is? Like if you had 1 minus x times, 1 plus x, it'd be a difference of squares. So this becomes, this part right here, just to save a line because it's so long, this is going to become 1 minus cosine squared of x. Okay, because of difference of squares. I'll just make a note of that. Now, you don't have to write that, obviously, when you're doing the problem, but just for if you go back, you see why we did it. So I now have, I'm going to rewrite this, sine of x times 1 plus cosine of x all over 1 minus cosine squared of x. Now, what is this on the bottom? And it's equal to what?
Sine squared x.
So it's sine squared of x. So now, and I can do this because it's multiplying, okay? If I had already multiplied sine of x through, I couldn't do this, but because I left it and I haven't multiplied it through, typically I will save anything in the numerator to be multiplied until the very end because of stuff like this. So because this is being multiplied here, I can cancel this sine of x with this squared part to be left with 1 plus cosine of x over sine of x. But if I had already multiplied, I wouldn't be able to do that. I would have to then split it into separate fractions and then go from there. Okay, ultimately it would work, but it would be more work for you if you did that. So now, I basically have a fraction with a common denominator, because don't forget my end result is supposed to be cosecant of x plus cotangent of x. So I'm going to split this to be 1 over sine of x plus cosine of x over sine of x. Okay, and I can do that because it had the same denominator. So then 1 over sine of x is cosecant of x, and cosine over sine is cotangent. And that's equal to what it asked for. So it was good. And it theoretically could have originally, the right side could have said this, and that's where we would have stopped. It's not always to say that when you get to the ending point where they want you to end, that that's the farthest you can go. Now in this case it is, but it could have been that they asked me to stop here, and that would have been fine. Okay, you're stopping wherever their right side is telling you to stop.
So how did you And cosecant, cotangent for adding that?
So 1 over sine of x is cosecant, and then cosine of x over sine of x is cotangent of x.
Okay.
So, and I was able to split it because of the common denominator.
Okay.
If you had multiplied this through up here, basically you would have ended up with 2 separate fractions, and then you would have been reducing your fractions, which ultimately would have given you this. I just think it's easier to save you work from, like, don't multiply and then have to unmultiply, if you will. So, any questions about those? All right, then to add to what you had yesterday, and then you can submit it all at once, because I didn't make a tab yesterday, did I? I don't think. Okay. This is all except for one of the functions, or one of the problems in that section, because it is a much harder problem. So we're gonna skip it. At least for now. It might be one of those that we come back to at a later point, but I wouldn't give you something as hard as 33 on the test. So